Hello, everyone. In this video, I will introduce our new work, Move as You Say, Interact as You Can, Language-Guided Human Motion Generation with Scene Affordance. In this work, we introduce a novel two-stage framework that leverages scene affordance as an intermediate representation to facilitate language-guided human motion generation in 3D scenes. In our daily lives, humans can interact with the surrounding environment by following language instructions. Now, transpose this scenario to a virtual realm with a humanoid agent. Our goal is to ensure the agent's movements are not only semantically consistent with the description, but also physically plausible within the scene. However, generating plausible human motions remains daunting due to two primary challenges. The first challenge stems from the inherent complexity of marrying 3D scene grounding and conditional motion generation. This complexity poses hurdles for existing diffusion or CVAE models to generalize to novel scenarios. The second challenge lies in the generative model's dependency on large volumes of high-quality paired data. Regrettably, existing human-scene interaction datasets still fall short of simultaneously meeting the requirements of large-scale, motion diversity, and semantic richness. Given a 3D scene point cloud and language description, our goal is to generate a plausible motion sequence. To address the aforementioned challenges, we propose to utilize the scene affordance map as an intermediate representation. Derived from the distance field between human skeleton joints and scene surfaces, this representation offers two key benefits. First, it precisely delineates the region grounded in the description, enhancing the 3D grounding even with limited training data. Secondly, it provides a nuanced understanding of the geometric interplay between scenes and motions, aiding the model's generalization across diverse scene geometries. Based on this intermediate representation, we introduce a novel two-stage model to effectively link 3D scene grounding and conditional motion generation. Given a 3D scene and language description, we first predict an affordance map. Then, the second stage generates human motion from the description and pre-predicted affordance map. Let's delve into the specifics of the first stage. We introduce an affordance diffusion model to learn the distribution of language-grounded affordance maps. ADM's architecture draws inspiration from the perceiver model, which leverages an attention mechanism to efficiently extract pointwise features. The second stage involves an affordance-to-motion diffusion model to generate plausible human motions. AMDM comprises an encoder specifically for the affordance map and a transformer backbone that integrates multimodal features to facilitate motion generation. We first evaluate our method on the widely recognized text-to-motion benchmark, HumanML3D. The following table presents the quantitative results. Our approach surpasses all baselines in terms of the FID metric. Notably, compared to MDM, a leading diffusion model in motion generation sharing a similar transformer backbone with ours, our method demonstrates superior performance. Let's take a look at some generated results from the test set. These visually appealing outcomes are consistent with the provided language descriptions. Next, we evaluate our model on Humanize, the first extensive and semantic-rich human-scene interaction dataset. From the quantitative results, our method exhibits a notable enhancement in grounding accuracy and physical plausibility. Further, the human study regarding the quality and action score suggests that human evaluators prefer our model's results. This slide presents visualizations of results from the humanized test set. These generated motions can correctly interact with the target objects with fewer collisions and increased contact. To assess the model's generalization ability, we curate a novel evaluation set by inviting Turkers to write diverse human-scene interaction descriptions within various 3D scenes. Our model enhances the FID score compared to baselines, and the improvements in contact, quality, and action score highlight its effectiveness in producing physically plausible and semantically consistent results. Here, we present the visualization results. It's important to note that our model has never seen these novel scene language pairs during the training. Our contribution lies in a novel two-stage model that incorporates scene affordance as an intermediate representation. It efficiently links scene grounding and conditional motion generation, facilitating language-guided human motion generation in 3D scenes. Through extensive quantitative and qualitative evaluations, we demonstrate our method's superiority over existing motion generation models across the human ML3D and humanized benchmarks. Despite the scarcity of language scene motion datasets, our model achieves impressive performance in generating human motions for previously unseen language scene pairs. Thank you for watching. Please visit our project website for more details.